In the last lesson, we implemented the first goal for our new guard, which was to verify whether an API token is present when a route is accessed. In this lesson, we'll be looking at how we can complete the next piece of functionality we needed, which was to detect whether the route being accessed is declared public or not. But how can we declaratively specify which endpoints in our application are public, or any data we want stored alongside controllers or routes? This is exactly where custom metadata comes into play. Nest provides the ability to attach custom metadata to route handlers through the setMetadata decorator. The setMetadata decorator takes two parameters. First being the metadata key that will be used as the lookup key, and the second parameter is the metadata value, which can be any type. This is where we'd put whatever values we want to store for this specific key. So let's put this to use to learn how it all works. Let's open our coffees controller file, head over to our findAll method, and add this setMetadata decorator on top, making sure it's imported from the nestjs/common package. Inside the decorator, let's pass those metadata key and value parameters. For our key, let's enter the string of isPublic. For our value, let's enter a boolean of true. This is the most bare-bones way of setting up metadata on a route, but it's not actually the best practice. Ideally, we should create our own decorator to achieve the same result. This is a much better practice because we will have less duplicated code, we can reuse the decorator in multiple places, and a custom decorator gives us much more type safety. Let's improve our existing code and make our own decorator and call it public. First, let's create a new folder within the common directory and call it decorators. Here we can store any other future decorators we might make. In this folder, let's create a new file called public.decorator.ts. In this file, we're going to export two things. One being our metadata key, and the other being our new decorator itself that we're going to call public. For our key, let's export const isPublicKey and set it equal to the string of isPublic, just like we called it previously. The benefit of exporting this variable here is that anywhere we might look up this metadata, we can now import this variable instead of using magic strings and accidentally mistyping the name. Now let's export our decorator by entering export const public and setting this equal to an arrow function that returns setMetadata. Inside of setMetadata, just like before, we need to pass in that key and value. So let's use our isPublicKey variable. And for the value, let's pass in the boolean of true, just like we did previously. And that's it. We just made our first decorator. Next, let's swap out the code we previously added in our coffees controller to use our new decorator. Let's head back over to that findAll method signature and replace the previously added setMetadata expression with this public decorator, making sure to import it from our local directory. Perfect. We now have a much more future-proof and easily reusable decorator that we can use throughout our entire application if needed. Let's tie everything together and fix up that API key guard to use it. Currently, our guard returns true or false depending on whether the API key was provided with the request. But now we need to add our isPublic logic here. We need the guard to return true when the isPublic metadata is found before continuing further and testing whether an API key is present. In order to access the route's metadata in our guard, we'll need to use a new helper class called Reflector. The Reflector class allows us to retrieve metadata within a specific context. This class is provided out of the box by the Nest framework from the Nest.js core package. Let's inject the Reflector class here inside of our constructor. Now we can use this provider within the canActivate method to retrieve the metadata of our handler let's add a new variable called isPublic. For this variable, let's utilize this.reflector.get, which looks up metadata by its key. In our case, the exported variable isPublic key we just made a moment ago. Reflector requires a target object context for the second parameter. In our case, we want to target the method handler in our given context. So let's pass in context.getHandler. Just for reference, if you needed to retrieve metadata from a class level, you'd call context.getClass here instead. For more information on Reflector and other possibilities here, read more about it in the Nest.js documentation. Okay, great. Now that we have the value from our decorator inside of our guard, there's one last thing we need to do. If a route is public, we can simply skip the validation of the API key. Let's add a simple if statement, and if isPublic is true, let's just return true. And lastly, we mentioned earlier that we shouldn't use process.env directly, so let's fix that and instead use the config service. Let's move into the constructor real quick and inject config service. With this service injected, we can now replace the previously used process.env.api key call with this.configservice.get, passing in the string of API_key. Let's save all of our changes and check the terminal to make sure everything is compiling correctly. Okay, so our guard is ready, but it looks like the application couldn't bootstrap properly and it is throwing some compilation errors. Well, what happened? Well, these errors appeared because we're using dependency injection inside of our guard, which was instantiated in the main.ts file. So how can we fix this? As we showed in previous lessons, global guards that depend on other classes must be registered within a module context. Let's fix this real quick and add this guard to a module. And actually, let's take it up a notch and create a new module for our common folder, and we can instantiate our guard there. Let's fire up another terminal window, and let's generate a module and call it common with nest.gmo common. This will generate a module class where we can register any global enhancers we might make in the future, including our API key guard. Great, so let's open up this new module and utilize the custom provider setup we learned in a previous lesson. This is where we pass in an object into our providers array, providing a specific class or key, and then the value to be used for it. Inside of our module decorator, let's add a providers array and pass in an object with provide app_guard and use class with our API key guard. This setup is very similar to using use global guards that we had in our main.ts file, but as we said, that option is only available if our guards do not use dependency injection. Note that there is a way around that, but it isn't a best practice since you'd have to manually pass in dependencies. One last thing here, let's make sure to import the config module in an imports array here, so we can use the config service in our guard. Now let's open up our main.ts file and remove that use global guards line since we don't need it anymore, and save all of our changes. Let's switch to our terminal window again to make sure everything can bootstrap properly now. Great, everything's compiling again. Now let's open up Insomnia and put our new guard to the test. Let's start by removing the authorization header and make a get/coffees request, which we set up to use our public decorator. If everything works as expected, it should not return a 403 error since our guard should allow access to it. And it worked great. Next, let's try a route that doesn't have the public decorator, like a GET request to the endpoint coffees/1. Our guard should deny us access to this route since it is neither public nor are we passing in an authorization header. And there it is, 403 forbidden. Our guard works perfectly. So to wrap up, we covered a lot of ground in this lesson, tapping into a lot of concepts we learned in previous lessons. Now we have the additional power to create our own decorators and utilize handler metadata, useful for anything our application might need in the future.